I'm recording. Arr, arr, arr.
Hi there, I'm Caden Scully. And did you know, Newton was one of the greatest scientists of all time, and he discovered the most important thing to make the universe and physics work. Newton came up with the 3 laws of motion that everything in the known universe have to follow. Anything you ever want to do involves Newton's 3 laws of motion. Want to go swim with some whales? Can't do it without the 3 laws. Want to run someone over with your Ford F-150? Can't do it without the 3 laws. Newton's first law is inertia. Inertia means objects in motion stay in motion, and objects at rest stay at rest. Or OISM and ORSAR. Newton's second law is a formula. F net equals ma, or net force equals mass times acceleration. Newton's third law is the most well-known of the 3, and it is every action has an equal and opposite reaction. Newton's 3 laws are very important for the world, and without them, very, very weird things would definitely happen to the world. Good luck with the video. See you later. Inertia.
Newton's first law of motion is the law of inertia, which states that objects in motion stay in motion, and objects at rest stay at rest.
Here's a quick example of objects at rest wanting to stay at rest.
ORSAR.
Watch how Wile E. Coyote runs.
This is an example of inertia because his legs are moving and trying to go forward, but he's staying still because objects at rest want to stay at rest. This is another example of inertia, and objects at rest wanting to stay at rest, because even though there's a force being applied to the glasses to get them to move with the tablecloth, they stay there due to inertia. This is an example of another type of inertia, where objects in motion want to stay in motion. Since there's minimal resistance on the Earth, it keeps spinning and spinning, and since it's so big and heavy, it's almost impossible to make it stop or even affect it. So, the larger the mass of something, the greater its inertia. This is also why it's so difficult to push heavy objects, like a house. This is another example of objects in motion wanting to stay in motion. The motorbike comes to an abrupt stop, but the inertia of the person riding the bike makes them keep going forward, even though their bike is stopped.
F net equals ma. Newton's second law of motion is net force is equal to mass times acceleration. As you can see, wagons move. This is an example of Newton's second law because it demonstrates the fact that with more weight in the wagon, it takes more force to move it at the same speed. This is a boy in the wagon. He's pretty heavy, so this is gonna be pretty heavy. We'll see how it goes.
Oh, he's having trouble. He's trying his best. I'm barely moving here. I'm not going anywhere here.
So much force is needed.
Alright, I've moved a meter.
When the wagon is empty, it is relatively easy to pull, but when it has a person in it, it becomes much, much harder to pull, meaning it takes more force to pull the wagon. So much force is needed. Throwing contest.
I've got a weight and I've got a ball. We're gonna do a throwing contest. Let's see which one goes further. Hi, I'm Sarms. I'm gonna be throwing this weight. I have a really good arm because I lift weights. So I think I'm gonna throw it further. On the other hand, Steve, who kicks balls, all the time. He has to kick the ball. I don't think his arm's gonna be very good. So I think I'm gonna be able to throw this further.
I'm Steve.
Sarm doesn't lose. Here we go. Pretty solid.
I'm Caden Scully, and I will be reporting this sports event for the day. So, first of all, we've got Sarms. He threw his weight not very far. Now we'll go see Steve's. And this is where Steve threw it. As you can see, it was a little bit farther than where Sarms threw it. This demonstrates Newton's second law because the heavy thing was not able to go as far because it was heavier and took more force to move. Steve won. Newton's third law.
Newton's third law of motion states that every action has an equal and opposite reaction. Pushing off the wall shows that all the force you put into the wall also comes out of the wall back into you, causing you to move with the same amount of force you put into the wall. When someone pushes someone else, they tend to fall backwards a little bit too. This is because of Newton's third law as well, since whatever force you push the person with also gets applied to you. This is why when you push someone bigger than you, you'll likely fall back farther than they do, since you're easier to move.
In conclusion, Newton's 3 laws of motion are essential to our planet and our universe, and they're needed for everything to function properly. One last thing. Before Newton discovered gravity in 1687, people could fly. Thanks a lot, Newton. You messed up.
Hi there, I'm Caden Scully.
Boing, you know? You know what I mean?
Okay, next thing.
So the
Newton
boy-
came up with 3 laws of motion that every object in the known universe here follows.
Boing.
Wait a second.
Ha! Sorry, it's just chili.
Or SAR.
Oh no. Oh, it's chilly. Ooh, it's chilly. Oh, it's a car. Watch out, wagon, man.